Hello and welcome. In this video, I'm going to take you through the types of solids. This corresponds to the OpenStax textbook. We're in Chapter 10, Section 5. All right, there's only 4 types of solids you need to remember. I'll talk about how to recognize them, what their properties are, and some of the cool things about them. So here's a picture of most of all the 4 types of solids in this picture. You have 2 types of materials, amorphous and crystalline. We're mostly going to talk about crystalline materials today. So sodium chloride, we know, is table salt, and it's a regular arrangement of cations and anions. Ruby also is corundum, or Al2O3. This is a ruby laser rod. It's a synthetic ruby, but it forms different gemstones, and the color comes from transition metals entrapped within the corundum. So ionic solids are composed of ions. That's how you're going to know from a chemical formula. They're held together by ionic bonds. They're very hard, but they're brittle. Okay, they break and snap apart pretty easily, and they do conduct electricity when melted. Take a look at this YouTube video in the description below, and there's somebody that takes a Bunsen burner and melts table salt, and this light bulb in the bottom left of this photo lights up. So it does conduct electricity when it's melted or molten, but not when it's solid, okay? They have very high melting points, and they do dissolve in water to form electrolytes. Check out my other video on electrolytes for that, okay? There's this table on the upper right-hand corner of this slide, and I'll show you a summary table of all 4 types and all the different features as we go through, okay? So metals, for example, nickel is a metallic solid. This is not pure nickel, but copper is a pure metal, mostly in U.S. pennies, the older ones prior to 1980s. So anyways, copper is a metallic substance, and you can see lots of little balls arranged here in a crystalline material, a regular repeating solid as we're normally accustomed to viewing. Metallic solids are composed of metals. You could recognize them because they're in the left of the staircase, okay? They're held together by metallic bonds, which can be strong or weak, all right? They're all shiny, all right? They're malleable and ductile. They conduct heat and electricity, but they vary in hardness. It turns out you can cut sodium with a knife. You press right through it. And mercury is a liquid, okay? So that's not hard at all. And they have variable melting temperature, okay? Some metals have extremely high melting points, and things like lithium or sodium have very low melting points, okay? Here's depleted uranium. Uranium is a metal in the periodic table, and it's used in depleted munitions. It has a density and a hardness that's 1.6 times lead. So if an Abrams tank fires about 8 kilogram weight, depleted uranium shell at a metal object, it can just penetrate through because of its density and hardness. When that happens, of course, there's a sufficient amount of energy to volatilize the material, and it has chemical reactivity and radioactive reactivity as well. So it's not just a clean munitions. It leaves behind a lot of toxic byproducts after use, okay? Network covalent solids. Here in this picture, I have the glass jar. Silica, or SiO2, is glass, and it has repeating SiO units. And each silicon has 4 bonds in this little ball stick drawing. Each oxygen has 2 bonds. It can be amorphous, like if we're talking about window glass or just an ordinary glass cup. Or it can be crystalline if we're talking about quartz, those beautiful quartz crystals you see sometimes in the rock shops, okay? Another type of network material, so glass we're very familiar with, and also our pencils, all right? Graphite is made of carbon, and it contains repeating sheets of carbon, okay, shown in this little diagram here, and each carbon has 3 bonds, okay? Now carbon's unique in that it's soft, okay? Diamond, in contrast, is hard, glass is hard, but graphite is very soft, so it's used in lubricating locks. For example, squeaky floorboards. You can pick up powdered graphite from Home Depot and sprinkle that into the floorboards, so hopefully the wood won't rub against each other and make a squeak. And it's of course used in pencils, because as you write, it sheets and sheets and sheets of this graphite just fall off the tip of it onto a white paper. Okay. Graphite's unique in that it conducts electricity. It's used in batteries, for example, because of this property. It has an extremely high melting point. It really doesn't melt. It actually begins subliming at 3,600 degrees Celsius. So they make graphite crucibles that can be heated up with a flame to very high temperatures, and you can melt gold and other metals in there and do experiments. And it's found in pencil lead. It's not really lead, it's pencil. It's graphite. Okay, I'm not sure if you can see this on my hand here, but yeah, you can't see it. But when I was a kindergartner, I stabbed myself with a pencil, and I got this little pencil scar on my skin, and that's graphite. It's very unreactive, and some tattoos are made from graphite, which is the black color of those tattoos. All right, so let's review. There, you basically have to memorize the 4 common types of network covalent solids. Okay, these are network covalent solids. They're solids, and they're made with covalent bonds. And on the very left, we have diamond, which is made of carbon. And on the very right, we have graphite, which is made of carbon. Those differ in terms of hardness, price, quality, clarity, and so on. And then you got a couple in the middle. Silicon dioxide is glass or quartz. Okay. And then silicon carbide is that third one over. Silicon carbide is kind of similar structure to diamond, but it's much cheaper. It's used in cutting tools and things like that. Okay. Saw blades and stuff. All right. And the properties are down there too, so you can take a look at those. All right. The 4th type of solid is molecular solids, and these are composed of neutral molecules. Molecules can be quite big, like sucrose, for example. Okay, C12H22O11. Sorry about that formula there. Naphthalene is mothball, C10H8. We've discussed the intermolecular forces there that are quite weak, and so naphthalene can sublime quite readily. And ice is H2O, for example. So these are all molecules that are composed of nonmetals held together by covalent bonds, and they can be solids. Okay. And so the nonmetals, remember, are on the right side of the staircase. So we've got a picture here of carbon dioxide in a repeating lattice, and we have a picture of iodine. Remember, iodine is diatomic, so it's I2, and they decided to use purple for the abbreviated color for iodine, which makes sense because iodine is a purple element. All right. So as I promised, here are the properties of the solids. You can find this in the OpenStax textbook. So you have the type of solid there on the left-hand side: ionic, metallic, covalent, and molecular. And you can see what types of particles we actually have present in there. Some of them are made of ions, some of them are made of molecules. And a diamond, for example, on a diamond engagement ring is one humongous molecule. Okay. There's different attractions there that you can see in some properties and some examples that we've gone over, okay? Let's work a couple problems now to see what you need to know. So here we want to identify the type of crystalline solid, whether it's metallic, network covalent, ionic, or molecular, formed by each of the following substances, all right? So we've got calcium chloride. So take a look at the first element, it's a metal. Take a look at the second element, it's a nonmetal. So that means metal, nonmetal combinations are ionic, and so that's an ionic substance, okay? The next one we have is SiC. What is that? Well, remember, you have to memorize these 4 types of network covalent compounds. And so silicon carbide is that third one over, right? So that's just network covalent. You're just going to have to remember that. N2, what is that? Well, this is a non-metal, so this is just simply a molecular solid, okay? At low temperatures, we've discussed this before, nitrogen can exist as a liquid, and even lower temperatures, it can be a solid, okay? It is possible. Fe, this is a metal, so what do? We know that it's a metallic substance. Okay, so these are the types of crystalline solids you might experience. You should be able to identify them, and then using those tables of reactivities, which one of these would be hard, which one would have a high melting point, which one would have a low boiling point, which one would conduct electricity, which one would not, and so on. Okay, so that's it for this presentation. Thanks for watching. Please like, please subscribe. Have a great day, everybody.